function okay. So a function f is this visible to all? A function f is twice differentiable okay on a closed interval ab, and fa equals to fb equals to 0, and f of c is less than 0 for some c in the open interval ab. Okay, is that the function f is twice differentiable on the closed interval ab, and fa equals to fb equals to 0, and f of c less than 0 for some c in the open interval ab. Then you have to show that, then prove that there is at least one point chi in the open interval ab for which f double dash chi is greater than 0. Okay, so do you understand what tells us this question? First of all, you have given a twice differentiable function and f and fb both are 0, and you have given that in sum between the open interval ab there exists a point c for which f of c less than 0. Then you have to prove that there exists at least one point xi in this open interval such that f double dash xi is positive. Okay, that means double derivative of this
যাইটা কি?
function at xi is any point in this interval, open interval. Okay, xi is any point.
আজকে মানে স্যার আমি আগে মেকানিক্যাল ছিলাম, মানে ইলেকট্রিক আমি নতুন আজকে এসেছি, আজকে প্রথম ক্লাস করছি আপনার।
Sorry,
বলছি আগে
first
মেকানিক্যাল
class.
ছিলাম, এখন ইলেকট্রিকে এসেছি, আপনার ক্লাস প্রথম আজ।
হয়।
আমি ভিডিও পেয়েছি।
You are from which branch? Okay, then try to solve this one. First of all, we have given that f double dash is exists. That means f is twice differentiable given, since f double dash exists on ab, close interval ab. Then what can we say about f and f dash? Then
f dash f এর ডেরিভেটিভ।
f double dash is double derivative of f. Okay, f double dash is,
হ্যাঁ স্যার, হ্যাঁ শুধু
okay,
একটা ড্যাশ হলো সেটা ডেরিভেটিভ হবে।
yes, single derivative is single dash and double dash is double derivative. Okay, since f double dash exists on the closed interval ab, then what can we about f and f dash? F and f dash both are what? Continuous. Okay, continuous on AB. If function is differentiable, then that must be continuous. Okay, now we have given that f double dash f and f dash both are continuous in this interval, and we have given a point C, and so we can say that this function is continuous also in a interval a to C and C to B. Okay, we can say that applying mean value theorem, applying mean value theorem, Lagrange's mean value theorem on A to C and C to B, we have what will be, if we apply Lagrange's mean value theorem in the interval A to C, then what will be the equation? This will be f of C minus f of A divided upon
C minus
C minus A equals to some f dash xi1, where xi1 belongs to the open interval A to C. Okay, and in the interval C to B, what will be the expression? F of B minus f of C divided upon B minus C equals to
C.
f dash xi2, where xi2 belongs to the interval C to B.
B to C.
Okay, C to B. Okay, we just break this interval A B into A to C and C to B. Okay, C is a point in this interval. So now we have given fa equals to fb equals to 0, but f of a equals to f of b equals to 0, which gives us, therefore, when we put fa equals to 0, then what will be the f dash xi? F dash xi1 is equal to f of c and c minus a, and f dash xi2 is what? fb0, then minus f of c upon b minus c. So this will be f of c divided by c minus b. Okay,
yes sir.
now we can apply mean value theorem to the interval xi1 to xi2. Okay, so now applying mean value theorem to the function f dash on the interval xi1 comma xi2, then we have what will be the expression? F dash xi2 minus f dash xi1 divided by xi2 minus xi1, and this will be some f double dash xi, where xi belongs to the open interval xi1 comma xi2. Is it okay? Now, what is f dash xi2 minus f dash xi1? But f dash xi2 minus f dash xi1 is what? In the expression f dash xi1 is what? F of c by c minus a, and f dash xi2 is what? F of c by c minus b. Okay. Then after simplification, you will get this one is f of c divided by c minus b minus f of c divided by c minus expression below. This one is c minus b into c minus a, and f of c common out, and c minus a minus c minus b. So this one will be what? B minus a. Is it okay? And you have given that f of c is what? In the expression, f of c is less than 0. Okay. F of c less than 0, and so this term is what? This term is positive. B is greater than a, f of c is negative, and c minus a is positive, and c minus b is negative, and f of c negative. So this whole term is what? Positive. Okay. Understand? So f dash xi2 minus f dash xi1 is positive, and so from the expression of f double dash xi, what will you get? Therefore, f double dash xi equals to f dash xi2 minus f dash xi1 upon xi2 minus xi1. This one is greater than 0, since xi2 is greater than xi2. Since xi2 greater than xi1, so xi1 xi2 belongs to also in the interval ab. Okay. Since xi1 less than xi less than xi2, so xi is between the interval between a and b. Therefore, f double dash xi greater than 0 in open interval ab. So understand? First of all, you just apply Lagrange's mean value theorem in the interval a to c and in the c to b. Then apply mean value theorem to the function f dash on the interval xi1 to xi2, and then you will get f dash xi2 minus f dash xi1 as positive, and then f double dash xi is your positive. So you have to prove this one, that f double dash xi is positive in the open interval ab. Okay. So any doubt? So then we'll do another example. If in the Cauchy mean value theorem, if in the Cauchy's mean value theorem, fx equals to e to the power x and capital Fx equals to e to the power minus x. Okay, then so that C is arithmetic mean between A and B. So what is the Cauchy's mean value theorem? Anyone? What is Cauchy's mean value theorem?
Sir, FB minus FA by GB minus GA equal to F
Okay.
dash C by G dash.
Okay. So according to Cauchy's mean value theorem, Cauchy's mean value theorem, we have FB minus FA divided by capital FB minus capital FA equals to what? Small f dash c divided by capital F dash c. Okay. Now we have given what? We have given small fx is e to the power x and capital Fx is e to the power minus x. So what will be the expression? So now FB minus FA upon capital FB minus FA equals to what? This is e to the power x, e to the power b minus e to the power a divided by e to the power minus b minus e to the power of minus a. Okay. So this will be equals to what will be the, if you common out from here, this one is e to the power b into minus e to the power a divided upon common out e to the power minus b, then this is 1 minus e to the power what? Just take out. Okay. So
AB.
simplify this expression. Okay, simplify this expression.
सर
First of
ओनली
all,
बी बाई ए होता है.
sorry. This is FB minus FA.
Minus
So FB minus FA is e to the power b minus e to the power a, and then e to the power minus b minus of e to the power minus a. Okay. So solve this expression as if you common out e to the power a, okay, from this b from first one, okay, then e to the power b minus a minus 1, and from this expression e to the power, okay, so this one is what, e to the power minus e to the power 1, and sorry 1 minus of e to the power
सर इसका सिंपलीफाई होगा सर माइनस ई टू द पावर ए
minus, okay,
प्लस बी
minus e to the power minus a plus b. So common out minus, then this expression is what, e to the power a plus b, and this one is minus common out, so 1 minus e to the power b minus a, and this one is 1 minus of e to the cancelled out. So this expression is what, minus e to the power a plus b, okay, so fb minus fa e to the power a plus b, okay. Now f dash c upon, now f dash c on capital F dash c equals to what, e to the power x, that means e to the power c, and minus of capital F dash c is what, minus of e to the power minus c, okay, this means minus e to the power 2c. So from this expression, what can we say, that from 1, write down this one as expression 1 and this one as equation 2, then from 1 and 2 we get minus e to the power a plus b equals to minus e to the power 2c. This implies c equals to what, a plus b upon 2, okay. So c equals to a plus b by 2. So we have to prove this one, that c is arithmetic mean between a and b, so c equals to a plus b by 2. Understand?
yes sir, yes.
Okay, so now you will just try to solve, this is your homework. If f of x equals to x minus 1 into x minus 2 and x minus 3, where x belongs to the closed interval 0, 4, then find c for the mean value theorem, okay. The second one, find c of the mean value theorem if fx equals to x into x minus 1, x minus 2, where x belongs to 0 to 1 by 2, okay. So these are two functions, okay. Just try to find out the value of c, okay, for which the mean value theorem are satisfied, okay. So next we will introduce another types of theorem, that's
सेकेंड इक्वेशन सर फिर से समझा देते हैं।
second equation is fx equals to x into x minus 1 and x
सेकेंड
minus
इक्वेशन
2.
क्वेश्चन का सर सेकेंड इक्वेशन सबसे ऊपर
Question
सर
का which one? जो
आपने
solve कराया
क्वेश्चन
था
सॉल्व
उसका.
किया उसमें सेकेंड इक्वेशन
Okay, okay. In second equation, what you need to find? F dash c by small f dash c by capital F dash c. Okay. So small fx is what? E to the power x. So derivative of e to the power x is what? E to the power x. And at c, this is e to the power c. And derivative of
समझ गया
f
सर,
of
हो गया ओके हो
okay.
गया।
So this one is minus e to the power 2c. Okay. So these two are questions. Try to solve this one at home. Okay. So find the value of c for mean value theorem. Now we'll introduce another uh, theorem which is called Taylor's theorem. Okay. So do you know Taylor's theorem? What is Taylor's theorem?
नो सर, नहीं था।
Okay. Okay. So Taylor's theorem is a expansion theorem. Okay. You know expansion or binomial expansion?
Sir.
You know binomial expansion? So binomial expansion is a general process for expanding some type of function or a plus x to the power n or 1 plus x to the power minus n, this type of function. So Taylor's theorem is a special case of some expansion or series expansion for various type of functions. Okay. So let's introduce the theorem. Taylor's theorem tells us Taylor's theorem okay, let a function f from closed interval a comma a plus h to r be such that number one f of n minus 1 is continuous on the interval a to a plus h. What is fn minus 1? What is fn minus 1? Fn minus 1 is n minus 1th derivative of the function. Okay. Number 2, f of n minus 1 is differentiable on the open interval a comma a plus h. Then there exists a real number theta satisfying 0 less than theta less than 1 such that f of a plus into f dash a plus h square upon factorial to f double dash a plus 2 h to the power n minus 1 upon n minus 1 factorial fn minus 1 a hn h to the factorial. Okay, f of n a plus theta h. Okay, where p is an integer less than equal to n. Okay, that p is an integer which is less than equal to n. Okay, and the last term, so this is the Taylor series expansion. Okay, if you have given a function and that function is differentiable in some interval, okay, then you can find the expansion of that function in a particular point like this. Okay, f of h is this one, where the last term last term h to the power n 1 minus theta n to the power n minus p divided by p into n minus 1 factorial fn a plus theta h is called remainder after n terms. Now write down some special types of remainder name. Okay, forms of remainder after n terms. Note down. Number 1, for p equals to 1 and denote this remainder as Rn. Okay, capital Rn. For p equals to 1, Rn equals to h to the power n 1 minus theta to the power n minus 1 divided by p into n minus 1 factorial f of n a plus theta h. Okay, this is called Cauchy form of remainder. Okay, number 2, for p equals to n, Rn equals to h to the power n, then f of n a plus theta h divided by n factorial. Okay, and this is called Lagrange's form of remainder. Okay, for if p equal to 1, Cauchy form of remainder, and for p equal to n, this is called Lagrange's form of remainder. Okay, this is the Taylor's expansion in the interval a to a plus h. Okay, now if we say that this interval is in between some interval, okay, then also this theorem holds. Let second form of Taylor's theorem if f satisfies the condition, if satisfies the conditions of Taylor's theorem in the interval a to a plus h, and x is any point of a to a plus h, then it satisfies the condition, then it satisfies the conditions in a to x also. Okay, so replacing a plus x by x, so replacing a plus h by x, or h by x minus a in Taylor series, what will we get? We get here f of a plus h is f a into h into f dash a. So f of a plus h is replaced by fx. So this will be f of x equals to f of a plus h is replaced by x minus
X
a,
minus
then f dash a, then this one is x minus a square upon 2 factorial, then this is f double dash a, and up to nth term x minus a to the power n minus 1, then n minus 1 factorial fn minus 1 a, and this is Rn. Okay, Rn is the remainder. So this is Taylor series expansion, okay, in a particular point, okay, a, and we just sync the interval from a to a plus h to a to x. Okay, so this is the Taylor's theorem or Taylor series expansion. Now, do you know Maclaurin series expansion? Then Maclaurin series is the particular case of Taylor series expansion. Maclaurin's
Sir, what is
theorem.
Rn?
Rn is the remainder, which I have denoted here. Okay,
ठीक है
Rn
sir,
is the
वो तो
remainder. Okay, there are many terms, so this Rn is the remainder term. Theorem, Maclaurin's theorem. Okay, write down this equation as equation number 1. Okay, putting a equals to 0 in equation 1, we have for x belongs to 0 to h, f of x equals to what? F of 0, put a equals to 0 in this expression, then this is x into f dash 0, then x square upon 2 factorial f double dash 0, then this one is x to the power n minus 1 upon n minus 1 factorial f n minus 1 0, then this is the remainder term. So this is the Maclaurin's series expansion. Okay, when you put x a equals to 0, then this is Maclaurin series expansion. Okay, now these are
सर
the
अभी पूरा
all.
नहीं लिखे
Sorry, fx is f of 0 plus x into f dash 0 plus x square by 2 factorial into f double dash 0, and plus then up to n minus 1th term, then this is Rn. Okay, Rn is the remainder
यस
term.
यस सर
Okay, so this is the finite series. Now we can write this as a infinite series. So when our Maclaurin's infinite series,
सर
infinite series. Just a minute, I have to take a call. Okay.
इसके बाद कोई क्लास है या नहीं?
मैकेनिकल क्लास आज है
11:40 क्या ক্লাস হবে না আজ? স্যারদের ক্যান্সেল করেছে নাকি আজকে?
আচ্ছা সারাদিন আর কোনো ক্লাস আছে না?
আচ্ছা ঠিক আছে।
আচ্ছা ঠিক আছে।
এ শফিক আছিস?
হ্যাঁ বল।
বলছি তাহলে মেকানিক্যাল ক্লাস বন্ধ নাকি আজকে?
হ্যাঁ হ্যাঁ
হ্যালো,
হবে না।
ঠিক আছে ভাই, ঠিক আছে, আমার একটু কাজ ছিল তো। ওকে।
Okay, sorry. So this is Maclaurin's infinite series. Okay, so we may easily deduce that when Rn tends to 0, okay, our remainder is what? Rm. When Rn is tending to 0, that is Rn is the nth term. When this Rn is convergent, okay, when Rn tending to 0, then as n tends to infinity, then the Maclaurin's series becomes fx equals to f of 0 plus x into f dash 0 plus x square upon factorial to f double dash 0, then plus x to the power n minus 1 to n minus 1 factorial fn minus 1 0, then this will go infinite terms. Okay, this type of series is called Maclaurin's infinite series. Okay, so for example, do you know the expansion of sin x? What is the expansion of sin x? If fx equals to sin x, then what will be the expansion of fx with Maclaurin series? So just try to find this type of expansion. Okay, so what is f dash x? So try to find f dash x. What is f
Cos
dash
x.
x? This is cos x, and f double dash x is
Minus sin x.
minus sin x. So what is f dash 0? And what is f of 0? F of 0 is sin 0, so this is 0.
0.
And f dash 0 is cos
1.
0, so this is 1. And then once again f double dash 0 is what? 0. Okay,
Yes, sir.
and then once again f triple dash x is what?
Sir,
Minus
minus cos x.
cos x. Okay, so minus
Minus
cos x, so f double dash f triple dash 0 is what? Minus 1.
-1.
So signs are alternating. So if you choose in this expression, then what is the expression? Then cos x sin of x equal to what? F of 0 is 0. Okay, then f dash 0 is 1. So this will be x.
আমাদের ভাই মাইক্রোফোন অফ
Then f dash 0 is 1. Then once again f double dash 0 is 0. So this is 0. Then you have f triple dash 0 is minus 1. So this one is what? X cube by 3 factorial. Okay, so
square
then your fourth term will be 0. Then your fifth term will be what? Minus 1. So then x to the power minus 5 by 5 factorial. Okay, that means if you have all the even terms are 0. Okay, all the even degree terms are 0. So this expression is what? X minus x cube by 3 factorial. Okay, so then if you find this one f triple dash x, and then if 4 dash x is what? This is plus sin x. Okay, and so f fifth order is what? Cos x. So this fifth order term is will be positive.
प्लस होगा सर
Okay, so this fifth order term will be positive. So this one is x minus x cube by 3 factorial. Then this is x to the power 5 by 5 factorial. And you know how to find the nth derivative of sin x. Okay,
सर x स्क्वायर बाय फैक्टोरियल 2 होता है ना
x square upon factorial 2, but x square term is vanishing because of x double dash 0 is 0. So only the odd degree terms are here. Okay, even degree terms are vanishing because of these derivatives at 0 is 0. So the sin x is what? X
Yes, sir.
minus x cube by 3 factorial plus x to the power 5 by factorial. Okay, then this will be minus x to the
x to
power
the power
7
7 by
upon 7
7
factorial. Okay, then this will up to the unit term. So this type of expression is called the this is the expression of sin x. Okay, actually the expansion of sin x is this one. Okay, so similarly you can find the expansion of cos x, expansion of tan x. Okay, every function trigonometric function has the expression of this form. Okay, you can find expansion of every trigonometric function. Also expansion of log 1 plus x. Okay, do you know the expansion of log 1 plus x?
Yes, sir.
Okay, so you can find the expansion of log 1 plus x also by using Maclaurin series expansion method. Okay, so find the Lorentz Maclaurin's series expansion of the function number 1 tan x log 1 plus x, okay, e to the power x. Okay, so find out the Lorentz. एक मिनट थोड़ा सा डिस्टर्ब तो सॉरी अब बार बार डिस्टर्ब करने के लिए, सॉरी गाइस। तो काफी लोग निकल गए। क्या हो गया, सब कहाँ निकल गए सब? चलो हाँ कंटिन्यू करेंगे, लेकिन ऐसे जब निकल जाएंगे फिर बाद में बोले समझ में नहीं आया, ठीक है? बीच बीच में छोड़ के चले जाते हैं सब। ओके, सो try to find the Lorentz series expansion of this type of function, also e to the power x cos x, then we try to find out the Lorentz series expansion of these functions. Okay, so up to this period, do you have any problem or any doubt? Then you can ask. Okay, so this up to this we have discussed about the variable one functions. Okay, so next we will introduce the function of several variables. Okay, up to this we have discussed all the functions are only involved single variables. Okay, that is y equals to fx type function. Okay, so up to this one, next we will introduce the several variables function. Okay, like a function of more than one variable. Okay, so will we start today? If you have
Sir,
any doubt, then you can ask. Okay,
sir,
Yes, sir.
Okay.
Start.
hello sir.
yes.
सर इस टाइप का सर थ्योरम का एप्लीकेशन क्या है सर? जैसे कि टेलर सीरीज और मैक्लॉरिन सीरीज, इसका सर एप्लीकेशन क्या है सर?
Yes, application is very vast. Okay, because if you have given a function, okay, then you cannot always find that function in a proper way. Okay, or you cannot analyze that function. If you read Fourier X series, then in the third unit you have Fourier series also. Okay, so there
Yes,
are lots of functions which properties are not always be discussed in a manual way. Okay, then you will just try to find the expansion of that function. Okay, if you are try to find a function in a particular point. Okay, I think you know the value of sine pi by 3. Okay, but if
yes,
I will ask you what is the value of sine pi by 100, can you say what is the value of
no
sine
sir,
pi by 100?
no
You
sir,
cannot say. Okay,
no sir.
then in that case, if you know the expansion of the function, okay, if you know the expansion of function, then you can directly find your expression for sine x is what? X minus x cube by 3 factorial. Okay,
Yes sir, yes sir,
so if you know the expansion of that function, then you can directly solve this one, and you can find approximate value of the function. Okay,
yes sir,
so this is the application, on type of application. And another way, you have lots of uh, functions where the general methods are not applicable. Okay, so you have to choose such function in such a way that their expansion is uh, very beautiful, and you can find a particular value of that function, exactly not particular, but particular value but approximated. Okay, because this is a infinite series. Okay, so the
yes sir,
value of the infinite series is approximate value. Okay, so you cannot you can approximate a function when you know the expansion of a function. Okay,
yes sir,
these are the basics of expansion. Later on, you will know about more expansion or more general. This is a for only convergent function. Okay, there are lots of functions which are not convergent, then you cannot apply this type of methods. Okay, then there are lots of series expansion which called Fourier series expansion, okay, Laplace series, this type of methods are there. Okay, so
Sir.
you will learn later on. Also in third unit I think there are Fourier series. Okay,
Yes, sir.
so we'll start our second several variables type of functions. Okay, so now up to this one we will discuss only the function like this, y equal to f of x. Okay, that means y is a function of x only. Okay, so this is a function of single variable. Okay, that means single variable means only in a line. Okay, because you have only one path. When you try to find a limit of a single variable, then what will you find? Limit x tending to a f of x. That means you are approaching the point only in a one way. That means if you have given a function and this x equals to a, then you are approaching or either left or right. There are only one way in the single variable case. Okay, that means you are when you are saying that you are in a one variable case, then you are just approaching in a one way or one path. Okay, you have only one path. But if you have several variables, that means you are one dimensional space. But when you have several variables, like if we say that this function is f of xy, okay, so then you have two variables. That means you have two paths. Okay, you approaching either in this way, in this way, in this way, or you can approach in another way. Okay, you have several paths. So when you have given that f is a function like z equal to f of xy, that means z is a function of x and y. So z is a the two variable functions. Okay, so now we'll discuss about the limit and continuity of several variables. Okay, so what is the limiting definition of in case of single variable? When we say that limit of a single variable fx, then we say that mod of fx minus l less than epsilon when mod of x minus a less than delta. This is the definition of limit in a single variable case. Okay, so what will be the definition of limit in the two variable case? In single variable we write fx equals to l as extending to a. So when we have two variable, then this will be limit x comma y tending to a comma b, where f of xy equals to l. This will be the limit. So this can be written as that limit of two variables. Write down mod of fx limit of several variables. Okay, function f of two f of x comma y is said to have a limit L if for epsilon greater than 0 there exists a delta greater than 0 such that mod of f of x y minus L less than epsilon whenever mod of x minus a less than delta and mod of x minus b less than delta. Okay, that means in this case you have 2 points. Okay, that means if you are given a function, okay, then you can move this either this way or this way or this way. Okay, left to right, right to left, or above to below or below to above, or either you can move by a line or you can move by any trajectory, okay, to this function. So or this can be written as also, this can be written as limit x comma y tending to ab fxy equals to L. Okay, if this is happened, then we can say that limit of this function exists. Okay, now fx, for example, if we say that f of x comma y equals to xy upon x square plus y square when x comma y not equal to 0 and 0 when x comma y equals to 0. So can you tell me what is the limit of this function? What will be the limit? First of all, write down this one is called when limit x comma y tending to ab, then this is called simultaneous limit. Okay, simultaneous limit. Now tell me what will be the limit of this function? First of all, see that if you will try to find the limit of this function as x comma y tending to 0 fxy equals to limit x comma y tending to 0 0 xy upon x square plus y square, then you cannot put directly limit in this function at 0 0 because this is 0 by 0 case. So you have to choose a path, okay, in such a way that this limit is vanishing out. Okay, you either choose let y equals to fx. Okay, you just limiting value means you are approaching to the function, okay, with respect to some function. So you just try to move as y equal to fx mx. Okay, then what will be the limit of this function? Then limit x comma y tending to 0 0 fxy becomes what? Then this will be when y equals to mx, then this is going to be a single variable function. So this will be what? X tending to 0 and y equal to mx means m into x square, and this is x square plus m square into x square. So this is limit x tending to 0, m upon 1 plus m square, x square vanish out. So this is a this is a term m by 1 plus m square. And what is m? M is a variable, m is any real number. Okay, so you see that when you approaches this function from a line y equals to mx, then this limit is m by 1 plus m square. So when you change the m, then your limit will be changed. Okay, that means what? Your limit is not unique. Understand what I'll say?
Finite number.
No, you just try to understand that when we say that limit exists, when limit exists, that means that limit L is unique. Okay, but when we approaches with respect to the function with respect to the line y equal to mx, then this limit is what? M by 1 plus m square. And m is what? M is a variable. When we will change m, then this limit will change. But when limit exists, we can say that limit is unique. But in this case, this is not unique. When we approaches m y equal to mx, okay, when m will change, then limit will be changed. So this limit is not unique. That means limit is not exist in this case.
Yes, sir.
Yes, sir.
Okay, so how will you approach? Okay, in second variable, you have to choose a certain path. Okay, if limit exists, then you can directly solve, and the limit will be, you will get the limit. But you have to choose some path. If in case any path the limit is not unique, then you can say that limit does not exist. You can also apply here polar coordinate also. You can also use x equal to r cos theta and y equal to r sin theta in this equation. Then what will be the expression? Then limit of xy is what? R square sin theta cos theta, and in the denominator, this is r square into sin square theta plus cos square theta. So your r square vanishing out, and this implies r tending to 0, and this implies limit of sin theta cos theta
By
Okay.
1.
and r square vanishing out. So your theta is what? Theta is a variable. Okay, your theta is a variable, and your r tending to 0. Your that means when you approaches by a polar path also, then your limit is what? Sin theta into cos theta, and this theta is what? Theta is a variable. Theta is an angle. Okay, that means if you have a path like this, okay, you say that this is your path. Okay, this is your circular path. Okay, you can approach by angle this, by angle this. If you can approach by any angle. Okay, when you change the angle, then your limit will change. Okay, that means your limit is not unique. So you can say that limit does not exist. Okay, now you have given that limit. If you have limit x like this, x tending to a and y tending to b, f of xy. Okay, what is the meaning of this? This means you first apply limit y tending to b, then this function will be what? Limit of x tending to a, this will be a function of x also only. Okay, when you applying this type of limit, double limit, that means you just apply limit first of b y and then apply a. This type of limit is called when you apply limit of y first and then limit of then limit of x, then this will be a function of x, and this type of limit, and you can also apply this type of limit also. First apply limit of x, this is b fxy, then this will be limit of y tending to b, and this is psi of y. Okay, so this type of limit is called repeated limit. Okay, first one is simultaneous limit, and this type of limit is called a repeated limit. Okay, simultaneous limit and repeated limit may or may not equal. Okay, for example, which I have done in the previous case. Okay, in that case, what is the limit of this one? Fxy equal to xy upon x square plus y square. So what is the repeated limit? When limit of x tending to 0, y tending to 0, xy upon x square plus y square. So what will be the limit? First apply limit as y tending to 0. So then this is what? 0. Okay, and then second limit is what? Y tends to 0, and limit x tending to 0, xy upon x square plus y square. This one is also at 0. That means your repeated limit exists, but you see that your simultaneous limit does not exist. In this case, we have seen. Okay, that means repeated limit and simultaneous limit may or may not be equal. Okay, note down, if repeated limits exist and equal, then simultaneous limit may or may not exist. Understand? So that means existence of repeated limit does not guarantee the existence of simultaneous limit. Okay, find limit x comma y sin inverse xy upon xy minus 2 divided by tan inverse 3xy minus 6. So what will be the limit of this equation? Limit x comma y tending to 2 comma 1 sin inverse x y minus 2 divided by tan inverse 3xy minus 6. Okay, so try to find the limit x comma y tending to 2 comma 1 sin inverse x y minus 2. Can you divide this by xy minus 2 and then multiply by xy minus 2, then divide this one by tan inverse 3xy minus 6 and 3xy minus 6 and multiply by 3xy minus 6. Okay, so what is the limit of this function?
xy
Limit
minus 2 by 3xy minus 6.
x comma y tending to 2 comma 1 sin inverse x y minus 2 by xy minus 2, and this one is what? Limit x comma y tending to 2 comma 1 tan inverse 3xy minus 6, and this is 3xy minus 6, and into limit of xy minus 2 and 3xy minus 6. So what will be the limit of this one?
1.
Sin inverse theta, limit x tending to 0, sin inverse x by x is what? 1. So this one is what? Xy minus 2 will be what? When you tends to x tend to y and 2 and y tends to 1, then this will be what? 0, tending to 0. Okay, and this will be also 0. So this is what? 1, and this is also limit x tends to 0. So tan inverse x by x is also 1. So this implies this is also 1, this is also 1, and if you common out 3 from denominator, then xy minus 2 is cancelled out. So this will be the limit. So this will be limit x comma y tending to 2 comma 1. So xy 2 by 3 into xy minus 2. So this one is 1 by 3. Okay. Now
सर लास्ट स्टेप सर फिर से एक बार
कौन सा last step? Okay, last step is which is multiplied x minus xy minus 2 and 3xy minus 6. These are multiplied. You have limit xy minus 2 and 3xy minus 6. So this term is 1. Also this limit of this is also 1. So you have only left limit of xy minus 2 by 3xy minus 6. 3 is common out from
हो
here.
गया समझ गया सर हो गया
Okay, okay. So this limit is your 1 by 3.
ओके यस सर हो गया
Okay, ठीक है. So that the limit exists at the origin okay, we'll try to some examples. So that the limit exist at the origin but the repeated limit do not where f of xy equals to x sin 1 by x plus y sin 1 by x when xy not equals to 0 and 0 when xy equals to 0. So you have to show that limit exist of this function but the exist. Okay, in the previous example we have seen that repeated limit exist and equal but limit does not exist. In this example we will show that repeated limit does not exist but limit of the function exist. Okay, so clearly you can say that what is the limit of y tends to 0? If limit y tending to 0 f of xy is what? Is limit y tends to 0 this function exist or not?
Exit. Does not
Limit
exist.
y tends to 0 x sine 1 by y plus y sine 1 by x. Okay, so is this limit exist?
No, sir.
This limit does not exist.
Yes.
Okay,
Because 1 by y.
this okay, so this is limit does not exist, does not exist. Similarly, limit of x tends to 0 if xy is also does not exist, does not exist. Okay, that means what? Therefore limit repeated limit x comma tending to 0 and limit y tends to 0 fxy and limit y tends to 0 x tends to 0 fxy does not exist. Okay, that means your repeated limit does not exist. Now you have to show that
सर एक बार और
limit of
repeat कर
this.
दीजिए.
Okay, you have to show that limit exists but repeated limit does not exist, and repeated limit is what? Your limit x tends to 0 and limit y tends to 0 fxy, and these two are not exist, then repeated limit does not exist. So if you have choose that limit y tends to 0 fxy, then limit y tends to fxy is not exist. That means what? Limit of this repeated limit does not exist, and limit of x tends to 0 fxy does not exist. That means your second repeated limit does not exist. Okay, that means your both repeated limit does not exist. Okay, so you can easily see that repeated limit does not exist. Okay, now we have to show that limit of this function exists. Okay, so how will you show limit exist? Now when mod of x sine 1 by y plus y sine 1 by x, can you write this on as mod Mod of a plus b is what? Mod of x sine 1 by y plus mod of y sine 1 by x, and this one can be written as mod of x plus mod of y, because mod of sine theta less than equal to 1. Okay, so also you can write this one as 2 into x square plus y square to the power 1 by 2. Okay, this modulus of two term is less than equal to this term. Okay, so this will be written as less than epsilon if x square less than epsilon square by 4 and y square less than epsilon square by 4. Okay, if x square less than epsilon square by 4, then this is epsilon by 2, and y square less than epsilon square by 4, so this is epsilon by 2, so 2 cancel out, so this will be epsilon. Okay, or mod of x less than epsilon by 2 and mod of y less than epsilon by 2. Okay, and you choose this one as delta and this one as also delta. Thus for epsilon greater than 0, there exists delta greater than 0 such that mod of x sine 1 by y plus y sine 1 by x less than epsilon whenever mod of x less than delta and mod of y less than delta. Okay, and what is the definition, epsilon delta definition of limit? Okay, this implies limit x comma y tending to 0 0 x sine 1 by y plus y sine 1 by x equals to 0. That means limit of this function exists. Okay, any doubt in this question? Okay, so try to solve these questions. So that the limit of the functions given below as x comma y tending to 0 0 does not exist. Okay, number 1, limit 2xy by x plus y. Number 2, limit x y cube by x square plus y cube y to the power 6, then find the limit of the given functions. Number 1, limit x comma y tending to 0 0 xy divided by square root of x square plus y square number 2, limit x comma y tending to 0 0 x to the power 4 plus y to the power 4 divided by x square plus y square. Okay, just try to find the limit of these functions. Okay, next we'll try to introduce continuity of several variables. Okay, in next lecture.
यस आज रहने दीजिए सर
Okay, आज के लिए इतना ही है.
सर सब
So
लोग
in
तो
next lecture we'll discuss continuity and then we'll introduce partial derivative. Do you know partial derivative?
यस सर
Okay. So when there are okay, we'll try to find partial derivative in a particular point. Then we'll introduce another kinds of partial derivative, higher order partial derivatives. Okay. So up to this one, we'll try it next time. Okay. So try to solve this problem and just revise the theory. Okay. So if you have any doubt, then you can ask. Okay.
सर हम लोगों के जो एग्जाम्स होंगे तो वो
हाँ.
ऑनलाइन ही होंगे तो उसमें सारे ऑब्जेक्टिव्स होंगे या फिर सब्जेक्टिव वगैरह होंगे क्वेश्चंस
सब्जेक्टिव मतलब क्या, जैसा क्लास में किया जा रहा है ना, ये सब क्वेश्चंस वगैरह ही आएंगे ना. ऑब्जेक्टिव तो नहीं होता ना सेमेस्टर एग्जाम.
ओ तो हम लोग का भी
ऑनलाइन
तो सीआरएस के एग्जाम होंगे ना.
ऑनलाइन एग्जाम जैसे होता है, क्वेश्चन दिया जाता है, फिर वो वैसे टाइम मिलता है ना, 2 घंटा जैसा भी टाइम होता है. उस
अच्छा
टाइम में लिखकर उसको फिर स्कैन करके भेजना होता है. ठीक है. तो
अच्छा
जैसा एग्जाम ऑफलाइन में होता है उसी टाइप का होगा, लेकिन शायद ज्यादा नंबर का नहीं होगा, ऐसा हो सकता है.
जैसे 100
पहले
मार्क्स
जैसे
का
हो रहा
होगा
था,
ना अभी हम लोग का मैथमेटिक्स का.
अभी ऑनलाइन में अब कितना होगा वो नहीं बता सकते अभी. ठीक है, ऑनलाइन में फुल मार्क्स का
मार्क्स का होता है.
हो नहीं रहा था. पहले जैसे हो रहा था 40 मार्क्स का हो रहा था, अभी कैसा होगा